Okay, let's start out with this number 4. This is asking us to find the general antiderivative of f of x and check that our solution is correct by differentiating. So to take the antiderivative of this, we would say that we're finding capital F, and you do it one term at a time. So do the antiderivative of that one. That one has a power of 1 for the x, and so you would add 1 to it, and then you're going to divide it by whatever you get. So this would be 9x to the second power divided by 2, plus our next one, we add 1 to the negative 2, and then we divide it by whatever you get after you add, so it would be negative 2 plus 1, which we know is going to be 1. So that's going to be 15x to the negative 1 over negative 1. And so our result after we do some simplifying or just manipulating to is 9 over 2x squared, and actually that's going to be a minus because 15 divided by negative 1 is going to be negative 15 minus 15, and actually let's do 15 over the x. So the x is going to go down because that's a negative exponent, and so you can take this whole thing, throw him down on the denominator, so now he's a positive 1 for his exponent. So that is the antiderivative of f of x. And don't forget, actually I almost forgot, you always got to have your plus c in there, because we don't know if that constant, what that constant is, if it's 0 or if it actually has a value that matters. So let's take the derivative of that. So we're going to take 9 over 2 x to the second minus 15 over x plus c, and actually I'm going to go ahead and rewrite this back to the way we had it. It would be 15x to the negative 1. So if we're taking the derivative of this, we would multiply this 2 to the 9 over 2, which would give us a 9, and then we would take 1 away from the 2, which would give us a 1. We'd multiply this negative 1 to the 15, to the negative 15, to make it a positive 15. That one's kind of bothering me. And then we take 1 away from that, so it would be away from the exponent, x to the negative 2. And then this is a constant, and whenever you take the derivative of a constant, you get 0. So you can say plus 0 if you want to, but that doesn't make sense why you want to do that. And it checks. So our antiderivative, if we take the derivative of our antiderivative, we get back to where we started. All right, here's another one. It's actually the same exact problem, except they're calling it an indefinite integral. Well, that's the same thing as the antiderivative. So let's go ahead and get busy with this. Now that's an integral sign. It just means you're going to take the antiderivative of that with respect to t. So the t is our independent variable. That's why we have a dt right there. The dt goes away after you do the antiderivative. So let's actually I'm going to split this one up and write it out. I normally don't do this when I integrate, but I'll go ahead and do this. Let's see, dt minus the integral of t to the negative 3 dt. Okay, so we're just taking the antiderivative of each of these. So I'm going to add 1 and then divide it by whatever I get. And I'm going to do the same thing right here, so negative 3 plus 1. Alright, so I get 5 t to the 4th divided by 4 minus, that would be t to the negative 2 divided by negative 2. And we have our plus c. Alright, let's simplify. Let's go 5. We'll simplify / manipulate. 5 over 4 t to the 4th. And then because we have a negative on this one, this is going to be a plus. We're going to have a 1/2 there. And because it's a negative exponent, I'm going to go ahead and put them down on the bottom with the 2. So we have t to the second power on the bottom plus c. Alright, so that's our answer for that one. We just integrated our indefinite integral. And now I'm going to test it. So we have 5 over 4 times t to the 4th plus this back. Let's see, 1 over 2, and we're going to say t to the negative 2 because they're like integrating that better. And then we have our c. Not integrating, taking the derivative up. Alright, so 4 times 5 over 4. 4 times 5 over 4 will give us 5. T to the third plus negative 2 times 1/2. That's going to be negative 1. So actually we don't want a plus there, we want a minus t to the negative 3. The derivative of a constant is 0, so it's gone. And we could see we got right back where we started from, so it works. Alright, really quickly, this rule is one that I was using. If you have addition inside of your integral, you can split it up like this. I normally don't split it up, I just integrate each of them. This is just a formal way to write it. If you have something you can factor out, a constant that you can factor out, you can put it out in front. And actually that'll make some of your integration jobs look a little easier. You notice that there's not a minus sign here. And that's simply because like we only have some. And that's only because the minus is actually can be factored out. So like if you had an integral of negative 3x dx, you can factor out that negative so it's in front. So what if you had like I don't know, 5x to the second power minus 3 dx. So if I did split this up, this would be 5x to the second dx, and then minus, we're taking that negative 1 out, 3 dx. So that's why you don't see the minus. It doesn't really matter. It's there.